Right. We are going in towards the territory of integration. Integral calculus, it's a topic by itself, and it's really an interesting topic. And by the time if you're at uni, you go up to triple integral, you'll get crazy. Alright, that's one thing that I still am grappling with, which is triple integral. Now, you won't be doing that at this stage, alright? You will be looking at single integral, that's it. And so you need to be able to link the idea of integral to the antiderivative and find the integral of a given function. Alright? At this stage, year 11, you're not looking at definite integral yet. You are looking at indefinite integral, alright? Which is practically the same as the antiderivative. But it's written differently, that's all. Alright, so the alternative notation for the antiderivative. So if I let fx be the derivative of that function or some function, alright? So the antiderivative is fx plus c. Use capital Fx. Alright? So or d dx of capital Fx plus c is the small fx. Or f dash capital F dash x equals fx. It's a notation. It's just alternative notation for your information. Alright. Now, what you really need to know is we are going to redefine the antiderivative. Anti-differentiation is a mathematical process which is dependent on knowing how to differentiate. However, the concept can actually exist on its own. This move away from the differential calculus into the field of integral calculus. Alright? Which means you will learn a lot more about this in year 12. So at this stage, we are going to look at anti-differentiation and integral as the same thing because we are looking at really indefinite integral. It's not a definite. Definite integral, you've got the lower and upper limit. And you use it for a lot of situation, mathematical situation. Like I say, by the time you come to uni, you've got the triple integral. That's the time that I got really confused. Alright, integration. Something that you should know. Integrals are the formal way of representing the collection of all possible antiderivatives of a function fx. So this sign is the indefinite integral sign. If there's definite, there'll be two numbers there. Alright, which is what, like I say, you'll learn in year 12. The indefinite integral symbol is the elongated s, which links to the idea that an integral is finding the sum of the area under a curve. Alright, so you will learn that you can use integration to find the sum of the area under a curve. That is when you have a definite. You know that from a curve, it could be x equals to 2 to x equals to 3. What is the area under the curve? Alright, so fx, the small fx, is called the integrand, the function that is being integrated. Dx denote the variable of integration, i.e. in this case we are integrating with respect to x. It could be dt, it could be dy, or could be dv or whatever. Alright? Capital Fx, we call it the indefinite integral of small fx. And plus c is the arbitrary constant of integration. So we link that to the family of solutions for antiderivation. Alright? So you could have any c. You don't know the c, but you don't know the c until you're given certain condition. For example, after you've integrated, you've got an x and y value, and then you can work out what the c is. Alright? So at this stage, we are not going to work on the sum of the area yet. It'll be next year. You are looking at that as an elongated s, which is integral. So you're integrating fx dx, and it will become fx plus c. It's just like the idea of antiderivative. Alright? Now let's move on. So the linearity property of integrals, the indefinite integral of a linear combination of function is the linear combination of the integral. All right, and also if you've got a constant in front of the integral, you can take the constant out. All right, so k fx dx, integrating that is actually k integrate fx dx, which means you've got that. All right, and then if you look at both of them adding together, you can integrate fx and then integrate gx separately. Now, in this case, you cannot, if you've got integrating fx and gx dx, at this stage, you've got to expand it first. All right, we haven't gone into the other way of doing it. At this stage, it's pretty basic, making sure that you know you're expanding fx and gx first. This, you cannot do it as fx times integrating gx. All right, this is not correct. So at this stage, if you've got the combination of fx times gx, make sure that you expand it first. All right. Now back to integration again. Now let's start with some examples. Pretty straightforward, these examples. So we normally have integration with a long symbol. This one you can straight away write the equal sign. That will be x squared over 2 plus x plus c. That's all. Pretty straightforward. It's a straightforward anti-derivative at the moment. All right. Let's try. I'll give you some time to do part B, part C, and part D. All right. Pause there for a minute. Give you about 3 minutes to do it. If you're not sure, this is the fourth root of p. All right, the quad root of p. So remember, if you got a radical function, write it as a index. Write it as an index. And also, preferably, go back. You might be specified to ask to keep the indefinite integration in radical form. Before you do that, just be careful with OTL. Some of the questions will go way over.
Sorry?
Some of the question in OTL is way too much for year 11.
Okay.
Sadly, it's a bit too simple, but OTL is a bit there.
That's what we are doing.
All right, I shall reveal my answer. You can check your answer against mine. B and C is pretty straightforward. D, you got to do a bit of rearrangement. So you need to make sure that you write your radical as in terms of an index. All right. So therefore, I know 2 over quadrat root of p is 2p to the power of minus 1/4. And then you can actually do your integration. All right. Now, another 2 examples. Have a look at A and have a look at B. So now, A, you must know how to expand the bracket. Alright, like I say, you've got fx times gx. So you got to multiply it in first. Whereas this one, you have to split the bracket. Alright? I split the sum or difference, not the bracket. Alright? It will be interesting if you see if you do it the way that I do it, or if you split it first. It's up to you. Make sure that you know you need to expand first.
Yeah, no, first.
B is an interesting one. Yep, you can do it that way, no problems at all.
I got some right. Because
Second one is interesting.
Four roots. I did it once though, I didn't screw it up for residential. You just do it.
One, that's the same one of
All right, got it?
Yeah, but you got it. It's the same thing. I know the same thing.
Yeah. Oh. 0.5 down. Is 0.5 is one of the two. Is one of two. Is one of the two. You don't have the 3 at the bottom.
Yeah. Then you put the negative out
This
front.
2t divided by half.
Plus the negative. Just make it negative.
Divided by half. Don't use decimal. If you use half, you'll see it. Yeah, got it. Because you use 0.5, you got yourself in the pickle.
So what's the final answer?
Yes, that's right. The same thing. All right. Got it.
Is this right?
Yep.
Is this right?
Yep. All right, I'm going to suggest that you don't even use decimal. All right? If you use decimal, you probably will get yourself into a little bit of pickle. I prefer to use fraction. Now, okay, I don't mind if you split it or you do the sum. This is a trick one. It could be either splitting or doing the sum because you end up with the same thing anyway.
So,
Hmm?
does it matter if we leave it as 4t a half? Or?
No, it's fine. I just generally recommend that because this is radical, you put in radical, that's all. It doesn't matter. That's what you've done is correct. There's nothing wrong with it. So, my suggestion is always make it into a fraction so that you don't have to divide by decimal. Alright? This is the one that a lot of people will make a mistake. Guarantee you. Guarantee. Because of the nature of this. You've got a radical, you haven't got one, you've got a radical here, you haven't got anything else. So, changing that into t to the power of 3 over 2, t to the power of 3 over 2. You can split it if you want to, or you can straight away just say 2 t to the power of 3 over 2. Which means it's 2 t to the power of, because 3 over 2 minus 2 is minus half, so 2t over half divided by half. Alright, so people get confused around here if you use decimal, and that is an easy mistake in the exam, in the test, especially under pressure. So it's 4t square root of t plus c. It is alright if you give me 4t to the power of half plus c, that's fine. Like I say, I just prefer it that way, that's all, because it's given, the question is in radical. This one, multiplication, multiply it in, alright?
2t.
And then, you know, therefore you got x to the power of minus 2, x to the power of minus 3. Remember, that's your index law. And then you can do your integration or antiderivation. Alright, so I'm going to stop here now. Everything from here, from Monday to today, or Tuesday to today, will be in the test. Alright? And that's it. So you now know you can link the ideal integral to the antiderivative, and you'll be able to find the indefinite integral of a given function.